Hello everyone. Let's look at the various states of. In the previous video, I discussed the process attributes. So all the attributes of a process, either it is process ID, process name, general purpose register, list of open devices, all are saved in a particular process control block, okay, PCB. So PCB contains all the attributes of a process, okay, and attributes of a process and even PCB both are called as context of process. So everything related to the process is called context of the process, okay. So this is very important. Okay, now let's see the states of process. So what is state of process? From creation of process till its completion, a process can go through various states, or a process can transit through various states called state of a process, okay. So whenever a process is created, then from its creation till the completion, it will go to the various states called state of a process, okay. And there are 7 types of states for any process is possible. The first is the new state, okay. It is the first state of a process. So new state denoted that a process is about to be created, okay. So whenever a process is about to be created, then it is residing in new state, okay. So a new process means a process is about to be created, okay, and it is residing in new state, and new state generally present in secondary memory, okay. It is present in secondary memory. So secondary memory means the hard disks. So it is present in hard disks, okay. Next state is ready state. So whenever a process is created, then after it will ready to run. So those processes which are ready to run will be present in the ready state. So it is ready to run, okay, and it just wait their particular time, so that the particular CPU will pick these processes and process them, and after it will complete their execution, okay. So ready state is present in the main memory. Main memory means RAM, okay. So new state is correspond to secondary memory. Ready state process is present in main memory. Now the third state is run. So run state denoted that a CPU picks some process for execution. So it is generally for CPU execution. So which process is picked by CPU? It will be decided by the operating system, okay, and then it will execute their particular task, and after executing the task, it will finishes its particular task. So run state also present in main memory. It will also present in main memory, and after CPU picks the process, and if it completes its execution, then definitely this process will finishes its task. So next, fifth state, which is a termination or completion, denotes that process finishes its task, and after finishing its task, it will be deleted, or it will be killed by a CPU or operating system. So whenever a process finishes its task, then it will go to the termination state, and termination state will generally operating system will generally kill or delete those processes which finish their execution time or finish their execution task, okay. So it is deleted or killed. Now The next state is block or wait. So whenever a process is let's say after creation, it will, if there is no hurdle, it will directly go to from new to ready state, then after ready to run state, and then run to termination state. Okay, so this is a very smooth way of executing a process. But somehow if let's say a high priority process come, or let's say a process need input output time, then this process will be blocked by CPU or operating system in block or wait state. So generally here input output task will perform, or let's say another high priority process come, then it will be forcefully, if high priority processes come, then the running process will forcefully wait in the wait queue. Okay, so it is high priority process. Okay, and block or wait state is also present in main memory. So you got it, ready state, run state and block or wait state generally resides in main memory, but new state resides in secondary memory, and termination is also in primary memory, but termination generally means finishes its task. So no need to visualize the termination state in terms of memory. Okay, now the sixth state is suspend ready. Suspend ready means, let's say a process P1 is picked by CPU 1, okay, and it executes their task. Suddenly a process P2 will come and its priority is high compared to the process P1. Then definitely CPU will pick the process P2 and it forcefully remove the process P1 from the CPU. Then if in the ready state, if it is forcefully removed by the CPU, then this process will be again come back to the ready state, and this is called suspend ready. Okay, so suspend ready is a special state when there is no space or no memories available for the ready state, then it will be residing in suspend ready. Okay, so whenever high priority process, or let's say if there is no space available in the ready state, then this process will go to the suspend ready, and it is in secondary memory. It is also in secondary memory. Okay, so I think you understood it, how suspend ready comes into picture. Whenever a process let's say run by CPU, and if high priority process will come, so the CPU will definitely forcefully remove this running process, and this running process first it will go to the ready state. But if there is no available space in the ready state, then this process will go to the suspend ready state, and suspend ready state is present in secondary memory. Similarly, if there is no space available in wait or block state for a process, then this process will go to the suspend wait or suspend block. So it is also in secondary memory. It is also present in secondary memory. Okay. So these are the process. So it will be more clearly visible if I draw the state transition diagram and show you how this particular process will transit their states from new to ready or ready to run. Then it will be more meaningful. Okay, so let's see them. In the next video we will see the state transition diagram of a process.